I do want you to flip over to the back side of your SGI 12.5. On the back, look at number 2 with me. This is just an extra example to go along with your section 12.5. My directions on the back side here, read your directions very carefully with me. Find the surface area, and when it says surface area, it means the total surface area of this pyramid. Okay? So take a look with me. What is the only 2 pieces of information they are giving you here? They're giving you this piece right in the middle. Now let me ask you, let's pause a second. Let me ask you about that piece in the middle. This is 8 feet right there. Is that going to help me at all find the area to any side or any face of this pyramid? No, it's not. We are not going to use 8 at all because it's not on the edge of any of the faces. But they're giving it to me so I can use that to find the stuff that I do need. I want you to take a look at the other thing they give you. They give you that this little angle right there is 45. When they give you your 45 degrees right in there, what are they probably wanting you to do here? They probably are wanting you to do some trig. Okay, so here's 45 degrees. Now also, can I look at this? Do you see this triangle here? 45, and then here's your 90 degrees. This is 8 feet. What kind of triangle is this? This is a 90 degrees, this is 45. Can you figure out what this other angle has to be? Doesn't it have to be 45? Check it. How do I know that? Because your total 180, and then if one's 45, the other one's got to be 45 to add with this 90 to make a total of 180. So what kind of what kind of right triangle is this? It's an isosceles right triangle. If these base angles are congruent, what can I say about the sides of this triangle? Isn't that side also going to be 8 feet? So will that save me a little bit of work? It sure will. If you notice this 45 and this 90, that other angle is always going to be another 45. It's always going to be isosceles. These sides are always going to be congruent to each other. Alright, so that was one piece that I did need, right? How is that going to help me to know that's 8? How does that help me with what I need? Let's think about what we're going for here. We are going for the total surface area. So I can just kind of draw a little diagram here to just lay out my net. I need the area of each one of these faces in order to add them all together. I know this little piece is 8. Where is that piece on my picture? It's right here. Can you see how that's going to help you with what you need? What kind of things do I need to get the area of this bottom piece right here? I need the length and the width. Well, this is a square. Okay, so what can I do down here at the bottom? If I know that from the center across is 8, then this piece here is going to be 16. Because on the other side here, this is also going to be 8. So if this is a regular pyramid, that means the base is exactly the same size on every side. So that means that this piece over here is also 16. So could I go ahead and figure out what's the area of my base? Sure. Remember, I need the total surface area, so I do need the area of the base this time. So the area of the base here is 256 feet squared. Now I just need to find all the little lateral faces, and then we can add them all up together. Let me ask you this. Is this little height going to also be 8? Is this going to be 8, 8, 8 just all around the place here? It's not going to be true. Okay, let me draw in. Do you see that this little black piece that I kind of highlighted here, isn't that going to be the height of one of your lateral faces if you were to lay this out? Can you see that? Coming from here, putting it on this picture on the net. Okay. That's going to be your slant height, the height of one of your lateral faces. Okay. So, is that going to be a useful piece for us? Okay, remember, go back to your thought process. Where are we going in the end? In the end, I want total surface area. So now I need to get the area of these little triangles. What is the formula that I need to use for the area of a triangle? 1/2 base times height. Do I need this little dotted line? Yeah, because that's your what of the triangle, that's your height. What is the base of every one of these triangles going to be? Hey, take a look at your picture. Don't you see 16 right here? Because down here 16, this piece right here has got to be 16. That represents the base of the triangle. The only piece that we're missing that we need is this slant height, or the height of your lateral face. Do we have enough information to find it? I want you to take a look. Let's go back to your original picture and let's look at this little triangle. They're giving you the 45 here. I pulled that off. It's over here. They want you to use trig. What piece do you need to find? I'm going to put an X right here, and that's representing that slant height. And take a look. That's going to represent this little height of the triangle that we need. Okay, so here we go. Can we find it? What would you do if you wanted to use trig? You could stand here, but since I filled in this other isosceles stuff, I have another method that I could also use. You can use Pythagorean theorem to set this up, because you already know 8 and 8 are your two legs. If you solve this, isn't that going to give you your hypotenuse? Yes, it is. Okay. For some of you, at this point, you like trig better than your Pythagorean theorem, for some of you. So I'm going to help you set it up. If you're just looking at this original picture, you were given this 45, you were given this 8, you need to find this, so we can ignore these other things. They will get in our way. Standing here, this is your opposite, this is your hypotenuse. What trig uses opposite hypotenuse? That is your sine trig. What always goes right beside your trig? Degree measure. Opposite is 8. Hypotenuse is x. Set up this proportion. Cross multiply 8 times 1. Divide by the sine of 45. It will give you exactly the same answer as doing Pythagorean theorem. Okay, so whatever your heart desires, pause the video, work it out, see what answer you can get, and then restart it and see if we get the same thing. Okay, down here, I chose to do Pythagorean theorem, and this is the answer I got for my x right here. Okay, so 11.3137. What is that going to be in my formula? I need that for the height. Now I'm ready to, oops, made a mistake here. 11.31. Here we go. 11.31 times 16, and then take half of that. The area that I just found was 90.48. Now, a lot of stuff going on. Pause a second. What did we just find? Over here, we just found 11.31 to find the height. We just plugged it into this formula, which is the formula for one of these triangles. We just found one of our lateral faces. Okay, so what are we going to do with that information? This is the area of one of these triangles. How many of those triangles do you have? You've got 4 of them. So let's take this number, multiply it by 4. There is your lateral area. I get 361.92. But take a look at your directions. It wants the total surface area. So take your lateral area, add it to this 256. Your final answer is 617.92. And I do need to finish it out, feet squared. And that is my final answer for number 2 on the back side of 12.5.